Now we will demonstrate building a new style from scratch using the Visual Style Editor. CMSS styling has implied default styles, and all enabled data layers will be visible using these when the list of rules is empty. First, let's fill agricultural areas with green and make them slightly translucent. You can see on the left-hand side the CMSS encoding of the style as it is being edited. Now we will select a beige color for settlement areas. Let's also show a thicker stroke of a similar color around them. Now let's symbolize roads. We will want to specify the width of the stroke in meters so that it changes with the scale at which we visualize them. We will also opt for drawing a thin casing around them, and let's make them gray. Now we will add labels to these roads. We first select the associated data attribute to display. The schema defines this ZI005_FNA as being the name of the roads. We will use this. We see that this data set has a lot of useless no information value for this attribute. We will define a selector based on that particular value to avoid drawing a label for these values. Now let's increase the size of the font slightly and make it bold. Let's symbolize lakes and rivers blue. Now let's apply styling to our elevation data. We turn on shading, tweak the intensity factor and sun elevation angle, and pick a color map. Let's see how this looks zoomed out. The thin casing is quite overwhelming at this scale. Let's define a scale-based selector to turn off the casing past a certain scale. We do this by setting a minimum scale denominator at which the casing width will be overwritten to be 0. Now our map looks good at any scale. Let's demonstrate how to use icons to symbolize points of interest. We select a layer with geometry identifying structures, and we associate an icon to a specific value for a feature code attribute. Since our icon is defined as monochrome, we can pick 2 colors by which to replace both black and white. Let's also slightly reduce the size of the icon. Our style is now complete. We can export it to CMSS, SLDSC, or Mapbox.gl style to use elsewhere. An important aspect which differentiates the CMSS encoding compared to both SLDSC and Mapbox.gl styling is its cascading and nesting mechanisms of portrayal rules. Rather than specifying the drawing order, the order of rules in CMSS controls the order in which symbolizing properties are being applied, allowing for nested rules, overrides, and easily defining complex multidimensional combinations. Now we will demonstrate importing it as a new style using the Interactive Instruments Styles API. Note that we could also have directly created and edited the style for the Interactive Instruments dataset without going through the export-import process. Here we can fill up some metadata for our style, such as a name, a description, and a stylable layer set, an identifier to describe which data layers it is intended for. We can also pick an encoding in which to save our style. We will first select Mapbox.gl styling. On the Interactive Instruments web interface, we can see the list of styles currently offered. We need to save the style to confirm that we would like to store it through the Styles API. Now let's verify whether we can see the style on the Interactive Instruments web interface. The web interface gives us the opportunity to test the style in a web map client. Now let's save another instance of the style using the SLDSC encoding. We can see both of these encodings for our styles are available from the Interactive Instruments Styles API. These styling capabilities are available and work the exact same way regardless of how the styles are encoded and whether accessing data tiles and styles from an OGC API or from an offline GeoPackage or GNOSIS data store, thus providing a consistent online-offline open portrayal framework.